Hello and welcome to our grade 8 physics class. The topic is measurement in science, and in this lesson we're going to define a physical quantity called density. We're going to calculate the density of solids and liquids, and we are going to see how the density of a body affects the body's ability to float or sink in a liquid. The following figure shows a sponge block and a wooden block, each placed on an electronic balance. Now the sponge and the wood block both have the same dimensions. This means that they have the same volume. However, we can see that the wood is heavier as indicated by the balance. Whenever two bodies have the same volume but different mass, we say that they have different densities. So how can two bodies having the same volume have different masses? Well, the density of a body depends on how the particles in the body are arranged. So if we look at the wood and the sponge, the particles in the wood are more closely packed together and irregularly arranged, whereas in the sponge there are more empty spaces between the particles. This means that there are more particles of matter in the same volume of wood as there are in the sponge, since the sponge contains more empty spaces. So equal volumes of the wood and the sponge will have different masses. The wood will be heavier. So the wood will have a greater density. The density of a body is defined as its mass per unit volume. The term mass per unit volume means how much mass there is in a volume of 1 centimeter cube or 1 meter cube of the body. The SI unit for density is the kilogram per meter cube, and another common unit used for density is the gram per centimeter cube. Aluminium has a density of 2.7 grams per centimeter cube. Now this means that 1 centimeter cube of aluminium has a mass of 2.7 grams. Pure water has a density of 1000 kilograms per meter cube. This means that a volume of 1 meter cube of water has a mass of 1000 kilograms. Let us now look at how we can calculate the density of a body. Suppose a body has a mass of 2000 kilograms and a volume of 40 cubic meters. Calculate the density of the body. Since we are calculating density, we need to find out how much mass there is in a volume of 1 meter cube of the body. So if 40 meter cube weighs 2000 kilograms, then 1 meter cube weighs 2000 kilograms divided by 40, which is 50 kilograms. So we say that the density of the body is 50 kilograms per meter cube. And as you can see, to calculate the density of the body, we took the mass of the body and we divided it by its volume. So the formula to calculate the density of a body is density is equal to mass divided by volume. Let us now look at a few examples. "136 grams of mercury has a volume of 10 centimeter cube. calculate the density of mercury. So using our formula for density, which is mass divided by volume, the mass of mercury is 136 grams and the volume is 10 centimeter cube. So 136 grams divided by 10 centimeter cube gives us a density of 13.6 grams per centimeter cube. The formula for density can be rearranged to calculate the mass of a body given its density and its volume, and to calculate the volume of a body given its mass and its density. So the mass of a body is its density multiplied by its volume, and the volume of a body is its mass divided by its density. Given that magnesium has a density of 1.7 grams per centimeter cube, let's calculate the mass of 100 centimeter cube of magnesium. So using our formula, mass is equal to density multiplied by volume. The mass of the magnesium sample is its density, which is 1.7 grams per centimeter cube, multiplied by its volume, which is 100 centimeter cube, which gives us 170 grams. Given that copper has a density of 9 grams per centimeter cube, let's calculate the volume of 180 grams of copper. So here we need to calculate volume given the density and the mass of the copper sample. We use the formula volume is mass divided by density, which is 180 grams divided by 9 grams per centimeter cube, and the answer is 20 centimeter cube. Let us now see how we can find the density of a liquid. To determine the density of a liquid, we need to find its mass and its volume. So in figure 1, an empty measuring cylinder is placed on an electronic balance. And in figure 2, 20 centimeter cube of a liquid is added in the cylinder. So first we calculate the mass of liquid in the cylinder, and then we calculate its density. The mass of liquid is the mass of the cylinder plus the liquid, which is 220 grams, minus the mass of the cylinder empty. So the mass of the liquid is 220 grams minus 80 grams, which is 140 grams. Since we are given that the volume of liquid is 20 centimeter cube, and we know the mass of the liquid, we can calculate the density of the liquid using our formula. Density is mass divided by volume. So that's 140 grams divided by 20 centimeter cube, which is 7 grams per centimeter cube. Note that when mass is given in grams and volume is given in centimeter cube, we will note the density in grams per centimeter cube. Next, let us see how we can find the density of a solid. So again, to determine the density of the solid, we need to find its mass and its volume. So to find the mass of the solid, we place it on a balance. So in this example, the mass of the solid is 27 grams. The volume of the solid, which is an irregular solid in this example, is determined using the displacement method. So in this example, 7 centimeter cube of water was placed in a measuring cylinder, and the solid was immersed in the water, and the volume of water rose to 10 centimeter cube. So the volume of the solid is 10 centimeter cube minus 7 centimeter cube, which is 3 centimeter cube. Since we now know the mass and the volume of the solid, we can calculate its density using density is equal to mass divided by volume, which is 27 grams divided by 3 centimeter cube, and the answer is 9 grams per centimeter cube. The density of a body determines whether it is able to float or sink in a liquid. If the density of a body is greater than the density of a liquid, the body sinks in the liquid. If the density of a body is less than the density of a liquid, the body will float on the liquid. So in this diagram here, body B sinks in the liquid while body A is floating. This means that the density of body B is greater than the density of the liquid. That's why it sinks. And the density of body A is less than the density of the liquid, and that's why it floats. We can see examples of this in daily life, such as a boat floating on seawater. This is because the boat's density is less than the density of seawater. If we place some cooking oil on water, we can see that the cooking oil floats on the water. This means that the oil's density is less than the density of the water. That's why it floats on the water. Let us look at the case where a boat made of a metal such as steel can float. Seawater has a density of 1029 kilograms per meter cube. Steel, being a metal, is much more dense than seawater. So how can a steel boat float? Well, to answer this question, let us look at a block of steel of mass 16,000 kilograms. The steel block has dimensions 2 meters by 1 meter by 1 meter. This means that its volume is 2 multiplied by 1 multiplied by 1, which is 2 meter cube. And its density is its mass divided by its volume, which is 16,000 kilograms divided by 2 meter cube, which is 8,000 kilograms per meter cube. This is the density of the steel block. In the second diagram here, the same steel block has been hollowed out, and its mass is now only 1500 kilograms. This is because there is now more empty space in it. Its dimensions, however, are still the same. Its length is 2 meters, its width is 1 meter, and its height is 1 meter. So its volume is 2 meter cube, just like in the case of the steel block. However, its density is now 1500 kilograms divided by 2 meter cube, which is 750 kilograms per meter cube. So this steel block here has a density which is greater than that of seawater, and it sinks. Whereas the hollow steel block has a density of 750 kilograms per meter cube, which is less than the density of seawater, and it floats. And this is how boats made of steel can float on water. To end this video on density, let us compare the relative densities of solids, liquids, and gases. Since the density of a body depends on the way its particles are arranged, solids have a greater density than liquids in general because the particles in solids are more closely packed together and there is less empty space in solids. Liquid particles are generally more spaced out, such that liquids have lower densities than solids, and the particles in gases are always very far from each other as compared to liquids and solids. There is way more empty space between gas particles, which means that gases have very low densities. Thank you for your attention and see you in the next video.